So you can be getting that out. So that means first, Tuesday night's homework, which was segment lengths, and the key was provided, and it looks like this. So that's the first thing. And then we have yesterday's completing the square homework. So first off, if there were any on this assignment, the segment lengths that you guys feel like we need to go over, let me know, and we will. And the next one would be this one. So if there were any questions you had on last night's homework, let me know as well. There we go. Excuse me. Absolutely. Last night's homework number 8, which was actually the only one I was asked all about in third period as well. So let's go ahead and do that one. Let's see what that looks like. Number 8. Okay. Okay, lots of different ways you could start this. Okay, you could start by putting it in standard form, or you could start by getting it set up the way we like to start our completing the square problems where they have the blanks. That's probably where I would go first. Somewhere in there, obviously, though, you're going to notice that you have a leading coefficient that's not 1. So right now, if I were to try to divide everything by 6, that would be yucky here and here. But if I put it in standard form first, or if I put it in completing the square form, so to speak, which would look like this, then everything here is easily divisible, or whole number divisible by 6. So I can go ahead and divide out the 6 and move on. So I would go ahead and divide both sides by 6. When you divide both sides by 6, you get p squared minus 2p equals 8. And I've still got my blanks ready to go so that I can start completing the square. Okay. Can you push the door shut? It's just a little bit more hall noise than usual. Thank you. That was the exact amount of pressure to apply. Very nicely done. It's very hard to do that, folks at home. You end up slamming it, or it doesn't quite make it. So Alex has mastered the art. All right, so here's where I take half of this number, which gives me -1, and I'm going to square that and put it here and here. As soon as I get this number, though, I already know what it's going to look like factored. So this side, when I fill this in, this will be the factored form. Okay, -1 squared is 1. So now I've completed the square. I've got it ready to start solving. When we solve by completing the square, we're really not solving by completing the square. We're solving by square root. Okay, we're solving by taking the square root of both sides. It's just that we had to complete the square to get ourselves to a point where we could do that. Okay, So I'm going to take the square root of both sides. That gives me p minus 1 on the left, plus or minus 3 on the right. P is not alone, so I need to add 1 to both sides. And we usually put it in front of the plus or minus. And then I can go ahead and simplify from there. 1 plus 3 is 4. 1 minus 3 is negative 2. And those are my answers. Okay. Any other questions on last night's homework? Yes, sir. Yes, I'm sorry, ma'am. Sure. Last night's homework number 1. Let me go ahead and minimize this and I'll be able to see it. Okay. It says find the value of C that completes the square. All right. Z squared minus 17C. Okay, so I'm going to take half of this number, and then I'm going to square it, and that's what goes here. Okay, so this is my answer, but we don't leave it in that form. We go ahead and do the work. So 17 squared, I believe, is 289, and 2 squared is 4. So that would be my answer. Okay. Other questions? Okay, so what we are going to go into today, and this is why we had to go back and remember how to complete the square, is equations of circles. And the standard form equation of a circle has a complete square for the x's and a complete square for the y's. So that's where we're going. So the first thing you need to do is write down what I'm about to show you. And while y'all are doing that, I will take some attendance, so you don't have to hurry too much. There you go. Sorry. Just trying to close out another window, and that made this happen. You'll go back 1 sec. Okay, so basically the main two things we do with circles in terms of their equations is we try to put information into this equation. We try to get the equation in this form, either from basically from any kind of several different scenarios, from given information about the circle, from another equation that's not in this form. There are several different ways we could start and be asked, give me the standard equation of the circle. The other way is we are given the standard equation of the circle and we're pulling information out of it, okay? And that is probably, of course, the easiest. So let's look at that real quick first. Let's say I have this. Okay, so here is the standard form equation, or the format for the standard form equation. And there are two things that really you could screw up here. All right. One is this. Because the standard format has minuses here, you have to realize that that means what you see is sort of the opposite of the sign. In other words, right here, x minus, everything matches. That means that h is 10. Y minus, everything matches. K is 2. So that means the center of my circle here is at 10, 2. Positive 10, positive 2. So if I see minuses, my coordinates are positive, which means if I see pluses, my coordinates are negative. Yeah. If I see x plus 3 squared, then if I'm comparing it to this form, that's the same as it being x minus negative 3. So since the basic format has a minus, we have to basically think of our signs as being different when they're in the equation. The opposite sign is what we see in the equation. If you see a plus in your parentheses here, your coordinate is negative. If you see a minus, your coordinate is positive. So that's one thing that you could mess up. Let's go ahead and just finish this one out. Let's say we have okay, this one would have a center at -3, -7 is what I'm saying. I see pluses, that means these are going to be negative. The actual point is negative. If I see minuses in the equation, then the actual point is positive. The other thing is that this is not the radius, it's the radius squared. So if we're outside the equation, if we're talking about the radius in any other context, if we're looking at the graph, if I'm telling you what the radius is, if I'm asking you what the radius is, it's just the radius. Radius is just the distance from the center of the circle to any point on the circle. But if we're looking at the equation, we're actually looking at the radius squared. So if you're taking the information out of the equation, you have to realize, okay, this is the radius squared. So my radius is actually 2. Okay, so here 10 is the radius squared. So the radius is square root of 10. Okay. Okay, so look at this one. Think about what your center, think about means don't blurt out. Think about what your center is and what your radius is. What's the y coordinate of your center? It's, what is it? If it were 1, wouldn't this say this? It's 0. Right, it's 0. If I don't see y minus anything or y plus anything, then what I'm subtracting or adding is 0. This means exactly the same thing as this. So if you just see x squared, that means x minus 0 squared. It means the x coordinate of your center is 0. If you see y squared, that means y minus 0 squared, which means the y coordinate of your center, or k, is 0. Okay, So that means the same as this. Okay, so our center is at 4, 0. And what's our radius? 4. All right, so if we're going to graph those, and I'm going to show you on a graph in just a second, but if we're going to graph a circle, just like if we're going to write an equation of a circle, those are the two things I need. I need to know the radius and I need to know where the center is. So I'm going to go over here to 4, 0. It would help if I had lead. And then the easiest way to do a circle is you basically go in your ways that you have a line drawn on your graph, which basically means horizontal and vertical. You go horizontally 4 in both directions and vertically 4 in both directions. So I go 1, 2, 3, 4 to the right. 1, 2, 3, was it 4? There we go. 4 to the left, up 4, down 4, and then I draw a circle between them. Okay, so let me show you what that looks like on a grid and do some more of those real quick. Okay, this is a sheet of some practice problems we are going to do together. All right, so look at both of those problems. Think about what your center is and what your radius is. Graphs. You're welcome. Okay, so my center for number 1 is where? 0, -2. Okay, make sure you got that's -2, not +2. My radius is where? 2. Or not where, is what? So I go to 0, -2, and I go up 2, left 2, down 2, right 2 from there. It can be easier rather than just holding your pencil down the whole time to do sort of brush strokes in terms of getting a good circle shape. So if you struggle to get a nice circle on your graphs, try doing that. Like little short pieces of arcs going around and just fill in. Questions there? All right, let's look at this one. What's my center? 2, 1. Agreed. What's my radius? Square root of 21. You got it. Okay. So I'm going to go to 2, 1. And then everybody tends to ask me, so how do you do it if it's a radical? Well, that's a number. That's just a number. And just like any other number, we're going to do the best we can on a graph. Because like if I said your radius is 3.2, you can't show it. You're not going to be able to look at a dot and tell the difference between if it was 3.2 units away from something or 3.3 units away from something. So easiest thing on these is just to estimate. You could use the calculator and change it to a decimal if you have trouble with that. But if I know that 21 is between 16, which is 4 squared, and 25, which is 5 squared, then it's going to be some number between 4 and 5. So I go a little bit more than 4 in every direction. 1, 2, 3, 4, and then somewhere between 4 and 5. 1, 2, 3, 4. 1, 2, 3, 4. We can't be real precise with decimals on a graph, so we just do the best we can. And closest. Okay, so estimate. And between two numbers is, I would just go with always just the middle between. It's not like I'm going to look at your graph and go, oh, that looks like she went 3.4 to the right instead of 3.3. You can't see that. So questions on that one? All right, let's look at these two. Figure out what the center would be, what the radius would be, and approximate the graph. All right, so on this one, my center is where? 2, 1. So right there. My radius is 3. So 3 to the right, 3 up. Ooh. 3 to the left, and 3 down. That didn't go well right there. Okay, so there's my graph. Where's the center on number 4? It's at the origin, 0, 0. This is x minus 0, and this is y minus 0. Okay, so my center is at the origin, and my radius is what? 4. So I'm going to go here. And there we go. Questions on either of those? Okay, so now we're going to go the opposite way. We're going to put things in equation form based on being given other info. Okay, so going back to here, a couple things I want to remind you of. When you are asked to write the equation for an anything, write the equation for this parabola, for this line, for this cubic, for this absolute value, for this step function, anything you're asked to write the equation for, your final answer, your equation, has to have the letters x and y in it, or maybe if it's a vertical line or a horizontal line, just one. But usually it has both letters, x and y in it, okay? Or else it's not an equation for all the points on that whatever. An equation for a line, equation for a parabola, equation for a circle. It's like a template that says all the points that are on this object would fit into this equation and make a true statement. Okay, so you have to have those places for you to fit the points in, the plug in there. So be careful that you recognize when you're being asked to write an equation in standard form, you're filling in the h and the k, which is the center, and you're filling in the r or the r squared. That's all you're filling in. Your final answer still has to have the x, still has to have the y. So we're filling in h, k, and r squared. Okay, so based on the way it's given to us, the two things we need are the center and the radius. And so if that's what we're given, that's very simple to fill in. That's all we do is we just fill it in. We've got exactly what we need. So center, that's my h and k. So x minus 7, y plus 3. Remember opposite signs because of the minuses. Equals 3 squared, so that's 9. And that's all I got to do to get my equation. All right, go ahead and do number 6. Okay, so starts out looking like this. Don't forget the squared. Don't forget the plus between the parentheses, or else you're saying something completely different. Then what's going to be on the right-hand side of this equation? 13. Don't forget that if you have something under a radical and you square it, that just lifts off the radical. If I square the square root of 2, I get 2. If I square the square root of 76, I get 76. If I square the square root of 13, I get 13. 7 and 8, same thing. I still need the center. I still need the radius. This time I'm pulling that information off a graph. All right, so the easiest way to me to get the center when you have a graph is to sort of think of it like crosshairs. And right there where those meet, that horizontal and vertical diameter, there's your center. So once you find the center, we got to get its coordinates. That's -1, 3. And remember, the radius is the distance from the center to the edge. This is not in the equation yet. We're just talking what the radius is. We're not asking about the radius squared. Just what is the radius? It's 2. 1, 2 units. And so then we plug in just like up here. So go ahead and finish this one and try this one over here. Okay, so this would be x plus 1 quantity squared plus y minus 3 quantity squared equals 4. You good there? Next up, we have the center is at 0, -4. The radius is 1. So I really don't need that parentheses. I'll go ahead and use it now that I've got it, but I'll go rewrite it afterwards. Best way to write this is that. There's no reason to write the -0 if it's -0. X minus 0 is just x. It's very easy to simplify. Don't forget, sometimes, and I think this is one of those not people misunderstand, but just aren't thinking. Sometimes people will square 1 and get 2. Okay, or try to square root 1 and get 1/2. 1 squared is 1, so square root of 1 is 1. All right, the next couple, we aren't just given the center and radius, even in graphical form. These I actually changed. For those of you, I gave a paper copy of it. I changed the points here because I don't like the points that were on there. Number 9 says the center is at -13, -16, and then here's a point on the circle. Okay, so let's look at how we would do that. Center is at -13, -16. And then we have some random point on the circle. It could be any point anywhere on the circle. This is not saying it's a special point. It's just a random point on my circle. So if we always go back to what does the equation ask for? It asks for the center and it asks for the radius. So those are the two things I need. I have one of them. One way to find the other one would be the distance formula. Okay. I could use the distance formula to find the radius, length of the radius, or the distance between these 2 points. And we're going to do that, but we're also not going to do that. So let me just sort of come back to that, circle back around at that. Let's think about what the distance formula says. Distance formula says this. You don't have to write any of this. Don't bother writing this, really. Okay, that's what the distance formula says. I'm going to write it the other way. I don't like having a radical, so I'm going to square both sides and get rid of the radical. Because I'm looking at a situation like this, one of my points already has its own special letter, so I'm going to use those. The center of the circle, we don't call x1 and y1, we call it hk. Now that I only have one x and one y, I don't need numbers. And we already said that the distance between those points is the what? Radius. That's the circle equation. That's all it is. The circle equation is the distance formula, because the definition of a circle is basically a definition about distance. A circle is made up of, or what it is it's the set of all points that are a certain distance away from the center. So since a circle is defined in terms of distance, the circle equation is a special case of the distance formula, just like the Pythagorean theorem is. It's just a different way of writing the distance formula. So we could do the distance formula here and get my distance between those 2 points and then square it and put it in the equation. But that's the less efficient way to do it, because I can do the distance formula just by plugging into the equation. In other words, if I have, this is my center, and I know any point anywhere on the circle, in this case, this is the point I know, that's an x and a y value on my circle. I can just plug these in right there. So x minus h squared plus y minus k squared. I don't know the radius, but look, this is going to tell me the radius. Or really, it's not even going to tell me the radius, it's going to tell me the radius squared, which is what I need if I'm trying to write the equation. So it's a much more direct route to what I'm trying to find. So negative 10 minus negative 13 is 3. Negative 9 minus a negative 16 is 7. That's 9 plus 49, which is 58, and that's equal to r squared. So now I know the center, and I know r squared, and I'm ready to write the equation. X minus a negative 13 plus y minus a negative 16 equals 58. Yes, I could find the radius by taking the square root of 58, but the whole point here was to write the equation. So the fact that I end up with the radius squared means you don't need that extra step. That would actually be an extra 2 steps, because you would have to take the square root and then square it again. So you are using the distance formula, but more efficiently by just using the circle equation. That's the easiest way to figure out what my r square is going to be when I have the center and I have some point somewhere on the circle. Questions about that? All right, so now you do it with the center being at 2, 3, and a random point on the circle is 0, negative 1. 0, negative 1. Write the equation of the circle in standard form, given that information to start with. Okay, so I'm going to take what I've got and plug it in. H, K, X, Y. This is why I made such a big point of that whole, an equation is a template and you need to see the letter X and letter Y, is a lot of times when we plug in a point to get something, to find something about our equation, people get confused and they leave it plugged in. Okay, and they say, here's the equation. If a point is plugged in, that's not the equation for the whatever it is. Circle in this case. That's just a number. All right, so we have X minus H squared plus Y minus K squared equals R squared. Negative 2 squared plus negative 4 squared. Please don't square a negative number and get a positive. I mean, get a negative, excuse me. It's always going to be a positive. So R squared is 20. So my equation is X minus 2 quantity squared plus Y minus 3 quantity squared equals 20. Sorry, let me move it up. Questions there? Now, if I was asked what is the radius, then I would take the square root. I would say the radius is square root of 20, and I would go ahead and simplify that. That's 2 root 5. What if I was asked what the diameter is? What would that be? Four root 5. Remember that whatever the diameter is, if you need to go from diameter to radius, you're taking half, where the diameter is twice as big as the radius. Okay? Next up, looking at these two last little questions here. This time it says I'm going to write the equation given the ends of a diameter. Ends of a diameter. Meaning, and this is not specific to that problem, but I have a circle. And you're telling me these points. Okay, that's what it means when it says given the ends of a diameter. All right. If I have the ends of the diameter, first of all, don't forget, what do we need to find? We need to find the center, radius. Always start with center. How do I find the center? How does the center relate to the ends of the diameter? What is it? It's the middle. What's that called? The midpoint. It's the midpoint. The midpoint of any diameter is the center of the circle. Anytime you have a midpoint of a diameter, that is your center. Remember, we have a midpoint formula. The midpoint formula just says if you want the middle point between two other points, get the middle x value by averaging the x's, get the middle y value by averaging the y's. So if I want the center of my circle and you're telling me what two endpoints of a diameter are, I'm going to use midpoint formula to figure out what the point is immediately between those. So for this particular one, if I want the point that's immediately between these two, let me get closer for those of you at home, it's a little bit small. The 2 points are 10, negative 13, and 4, negative 5. So I'm going to say, well, let's average 10 and 4. That gives me 7. Let's average negative 13 and negative 5. That gives me negative 9. So there's my center. Questions about that? Okay, now that I have the center and I know a couple of points that are on my circle, it's just like this problem. It's just like the problems we just did. I'm going to write the equation given the center and given a point on the circle. I actually have 2 points on the circle, so I could choose either one of those. I'm going to choose this one, smaller numbers. So it's like I'm being asked to write the equation for the circle that has center 7, -9, and a point on the circle 4, -5. Does not matter which point you choose because they're both on the circle. And then we're going to do exactly what we did on the last two problems. We're going to plug in. This is my x, y, h, k, x minus h squared plus y minus k squared equals r squared. -3 squared plus 4 squared. -3 squared is 9, 4 squared is 16, so r squared is 25. So my answer for my equation is x minus 7 squared plus y plus 9 squared equals 25. Questions on what I did there? You got to start by finding the center, and then you just plug everything in to find r squared. Let me let you try the next one. It has ends of a diameter are -10, 4, and 10, 2. That's number 12 here. Go ahead and try that one. The ends of the diameter are -10, 4, and 10, 2. Okay, so if those are two endpoints of a diameter, then the center of the circle is immediately in between them, the midpoint. The middle of -10 and 10 is just 0. The middle number between -10 and 10, right? So my center has 0 for its x-coordinate. And the middle between 4 and 2 is 3. The number right in between is the same as the average, is the same as the middle. We could also do that by 4 plus 2 is 6, divided by 2 is 3. So here's my center. So I can use either of those points as my extra point. I'm going to use 10, 2. So here's HK, 10, 2, sorry, is going to be my random point I plug in. And I'm going to get x minus h squared plus y minus k squared will give me r squared. 10 squared plus negative 1 squared. That's 100 plus 1 is 101. So I started to do parentheses. I don't need them because the x coordinate is 0. So x minus 0 is just x. X squared plus y minus 3 squared equals 101 is my equation. You guys all get that? Awesome. Okay, so your homework is already posted on Google Classroom. It's problems just like this. Tomorrow, we will get into the whole reason we did completing the square in terms of trying to put things in this format that start out in equation format, but not that one. Like we have an equation, but it's not written in perfect squares. That's what we will be doing. You guys have a quiz on Tuesday, I think it is. No, it's not. Your quiz is on Wednesday. Yeah, your quiz over this is going to be on Wednesday. I think it's my other class. Yeah. People at home, you guys all good? Any questions, comments, concerns? All right. See you tomorrow. Tomorrow is synchronous again. Happy Friday.